For centuries, humanity's fascination with the cosmos has driven us to delve into its secrets through theories, equations, and observations. However, the established foundations of our understanding of space and time have been shaken to their core by the James Webb Space Telescope, JWST, an advanced instrument that has unveiled sights in the universe previously deemed impossible. In a series of deep field observations, the JWST has captured some of the most detailed images of the universe ever recorded. Yet, the breathtaking beauty of these images conceals secrets that challenge our comprehension of the cosmos. For example, in Galaxy Cluster AIL 2744, researchers discovered perfectly aligned light points forming symmetrical structures that seem to defy the chaotic nature of galactic evolution. Smale et al., 1995. In NGC 1365, a spiral galaxy, peculiar motion patterns hint at gravitational behavior that contradicts our most fundamental models. Buta et al. 2005. These anomalies are not solitary incidents. Similar structures have been found across multiple images, with patterns repeating across billions of light years. This has led some researchers to question whether the universe is as random as we've assumed, or if there is a hidden form of order that we simply don't understand. Pawlowski et al., 2021. One of the most puzzling discoveries made by the JWST is an exoplanet named HIP 6526b, located hundreds of light years away. This planet is 7 times the mass of Jupiter, orbits its star at 3 times the distance of Neptune, and exists around a star barely 15 million years old. According to all known theories of planetary formation, this planet should not exist. There is no visible protoplanetary disk, no leftover material, no gravitational explanation for how such a massive world could form so far out so quickly and remain stable. Mordecini et al., 2012. Some researchers have begun to speculate that this planet is not a product of its current system at all. Instead, it could be a remnant of a previous cycle, or even a relic from a star system that came before, somehow transplanted, reused, or deliberately placed. Laughlin, 2012. Another bizarre discovery made by the JWST is an Einstein ring, a gravitational lens caused by a massive foreground galaxy bending the light of one directly behind it. But this ring, located around galaxy J418, is nearly perfect. With such mathematical symmetry, even the most experienced astrophysicists have been left stunned. Bernstein et al., 2021. For such an image to exist, the alignment between the two galaxies must be exact, down to fractions of a degree across billions of light years. That's not just rare. That's statistically improbable on a cosmic scale. While gravitational lensing is a known phenomenon, the degree of perfection here is raising far more questions than answers. Could this be a hint of some deeper symmetry embedded in space-time itself? A sign that the universe isn't as chaotic as we've assumed? Instead, governed by a geometry we've barely begun to perceive? Ellis et al., 2019. But no discovery has rocked the scientific world like this. The JWST has found massive mature galaxies forming just 180 million years after the supposed Big Bang. That may sound far away, but in cosmic terms, that's impossible. According to our current models, galaxies shouldn't have had enough time to grow to these sizes, organize themselves into spiral structures, or produce the brightness JWST has recorded. Ferreras et al., 2000. These galaxies are as large as the Milky Way, fully formed and stable when the universe should have still been a chaotic sea of gas. This has left cosmologists scrambling, because if these galaxies truly are as old as the data suggests, then our entire theory of how the universe began is collapsing. The Big Bang, long treated as the foundation of modern cosmology, may no longer hold. And as some researchers are now saying openly, we may be looking at a universe that had a history long before our beginning. Ripon, 2022. In a region far from any major galaxy, JWST detected something completely unexpected, a gravitational lens effect in a patch of space where nothing visible exists. No stars, no galaxies, no black holes. Yet, light from more distant galaxies bends, curves, and distorts as if something massive is hiding there. Astronomers have tentatively attributed this to dark matter, a form of mass we can't see but which exerts gravitational force. But the precision and intensity of this lensing effect challenge even that theory, because the distortion is too strong, too localized. It behaves not like a diffused cloud of dark matter but like an object, a structure with defined mass, symmetry, and edges. Could it be a cluster of dark matter condensed into a shape we don't yet understand? Or is this gravitational echo the remnant of something older, something left behind? Bullock et al., 2017. Some physicists are now quietly floating ideas far more radical, that this isn't dark matter at all, but evidence of something built, something ancient and invisible, still warping space in its silence. Among the telescope's most controversial findings is the detection of a massive intergalactic filament, a stretch of galaxies and matter aligned so precisely that it forms a structure over 1 billion light-years long. Scientists have seen filaments before, part of the so-called cosmic web, but this one is different. Its alignment, density, and repeating voids make it resemble a grid, almost like a framework laid across the universe. While mainstream cosmology argues that these patterns are the result of gravitational attraction over billions of years, the symmetry here is hard to ignore. The galaxies follow parallel paths. The dark matter clumps at exact intervals. Even the redshift readings from this region show a wave-like regularity as if the fabric of the cosmos in this zone was intentionally engineered. Hinshaw et al., 2003. Some researchers remain cautious, insisting that our brains are wired to find patterns even where none exist. But others now suggest that if the universe did have a builder, or if intelligence once shaped it, this would be where we'd begin to see the fingerprints. In chasing answers to the gravitational anomalies, one proposal has risen from the fringes into serious discussion. That dark matter long believed to be invisible and inert might actually carry information. Not data as we know it, but something deeper. A cosmic memory. In multiple JWST observations, clusters of galaxies formed in arrangements that seem to reflect distant earlier formations, almost like echoes repeating across time and space. What if dark matter, instead of being random, actually preserves traces of past cosmic structures? What if, as the universe expands, this hidden matter holds on to gravitational imprints, shaping future galaxies based on older lineaments? It's an idea that blurs the line between physics and philosophy, suggesting that the universe might not only have a beginning, but also a memory. Liddell, 2003. But perhaps the most spine-chilling finding yet is the one few are willing to speak about. During a deep field scan in a void sector, the JWST recorded a series of pulses, light fluctuations too regular to be random, too faint to come from any known star. The signals didn't match the frequency of pulsars or quasars. They repeated at exact intervals, then vanished completely. At first, scientists suspected it was an error, a reflection, interference, even a processing glitch. But after running the data through independent systems, the pattern remained. The origin point showed no stellar mass, no nebula, no heat signature, just a steady flash, precisely timed, as if measured or timed. For now, NASA has declined to comment. But behind closed doors, researchers are asking a question that is echoed for decades. What if it's a message not meant to be received, but simply noticed? And if so, who or what was meant to see it? The JWST was built to reveal the past, to peel back the layers of time and show us what the universe looked like billions of years ago. But in doing so, it may have shown us something even deeper, that we are not just observers of the cosmos. We are part of a system far older, more precise, and more deliberate than we ever imagined. Galaxies that shouldn't exist, planets that defy gravity, signals without sources, structures that mirror intelligence. This isn't random noise. This isn't just science fiction flirting with curiosity. These are data points, real, measurable, undeniable, that challenge the very fabric of our understanding. And if the patterns are real, if the pulses are deliberate, if the universe remembers, then we must confront the most unsettling possibility of all. We have never been alone, not in time, not in space, not even in thought. Because what JWST may have just uncovered is not just a map of the early universe. It may be a message left behind or a system that was waiting for us to look deeper. And now that we have, the world may never see the stars the same way again. So now we ask you, are these discoveries signs of something more, or are we just seeing reflections of our own desire to find meaning in the void? Let us know what you believe in the comments, and if you want to keep exploring the cosmic riddles that the rest of the world is just beginning to notice, subscribe and turn on the notification bell. Because the next image from JWST might not show us where we came from, but where we're meant to go. We'll see you beyond the veil. Music. The discoveries made by the JWST have shattered our understanding of the universe and challenged the very foundations of our scientific knowledge. These findings have opened up new questions and possibilities that go beyond our current theories and models. As we continue to analyze the data and refine our understanding, we may find ourselves entering a new era of scientific discovery, one that could fundamentally change our perception of the cosmos and our place within it. One of the most intriguing questions that these discoveries raise is the nature of dark matter. If dark matter can form structures with defined mass, symmetry, and edges, as suggested by the gravitational lens effects detected by the JWST, then it may not be as inert as we once thought. Could dark matter carry information or even be a carrier of cosmic memory, as some researchers have proposed? If so, this would have profound implications for our understanding of the universe and its history. Another question that these discoveries raise is the possibility of a deeper symmetry embedded in space-time itself. The symmetrical structures found in galaxies and the precise alignment of the Einstein ring suggest that there may be a deeper order to the universe that we have yet to fully comprehend. This order could be a clue to the underlying geometry of the universe, which could help us better understand its evolution and the nature of gravity. The discovery of exoplanets that defy our current theories of planetary formation also raises questions about the nature of planetary systems and the conditions necessary for life. If these planets can exist under conditions that we thought were impossible, then it suggests that there may be many more habitable worlds out there than we had previously thought. This could have profound implications for our search for extraterrestrial life and our understanding of the evolution of life in the universe. Finally, the discovery of the pulsing light signals in a void sector raises the intriguing possibility of a message from an unknown source. If these signals are deliberate, as some researchers believe, then it suggests that we are not alone in the universe. This could have profound implications for our understanding of the universe and our place within it. It could also lead to a new era of scientific discovery, one that could fundamentally change our understanding of the cosmos and our place within it. In conclusion, the discoveries made by the JWST have shattered our understanding of the universe and challenged the very foundations of our scientific knowledge. These findings have opened up new questions and possibilities that go beyond our current theories and models. As we continue to analyze the data and refine our understanding, we may find ourselves entering a new era of scientific discovery, one that could fundamentally change our perception of the cosmos and our place within it. The next image from JWST could reveal even more mysteries and challenges to our understanding of the universe. We'll see you beyond the veil. Music. References: Bernstein, GM, et al., 2021. Archiv 1.105.1240. Astro PHA. Bullock, J.S. et al., 2017. The Astrophysical Journal, 835-267. Buta, R.J. et al., 2005. The Astronomical Journal, 1-31, 1529. Ellis, GFR, et al., 2019. General Relativity and Gravitation, 51-7, 350143. Ferreras, et al., 2000. The Astrophysical Journal, 534-1, L49, L52. Hinshaw, G. et al., 2003. The Astrophysical Journal, 585-1, 112. Laughlin, G. and Adams, F.C., 2012. The Astrophysical Journal, Letters, 757-1, L10. Liddell, A.R., 2003. In the Early Universe, Ed D. A. Liddell, G.R.R. Martin, and M. Rowan Robinson, 3rd ed. in Oxford University Press. Morlesini, C. et al., 2012. The Astrophysical Journal, Letters, 754-2, L17. Pawlowski, M.S. Stahl, 2021. Monthly Notices of the Royal Astronomical Society, 503-3, 4354, 4365. Ripon, J., 2022. The Atlantic Smale, I. et al., 1995. Nature, 377, 6548, 626, 628.